Numbers untold. The man who knew infinity when gods whisper mathematics. 1914. Cambridge University, England. A letter arrives from India. Handwritten. Pages filled with mathematical formulas. Unlike anything the professors have seen before. No proofs, no explanations, just equations. Dozens of them. Beautiful, impossible, true. The letter is signed S. Ramanujan, a clerk from Madras with no formal training. The professor who reads it, G. H. Hardy, one of the finest mathematicians in the world, writes back immediately. These formulas must be true, because if they were not true, no one would have had the imagination to invent them. This is the story of a man who claimed a goddess whispered mathematics to him in his dreams, and the ancient tradition that made infinity feel like home. To understand Ramanujan, we must first understand India. While ancient Greece feared infinity, ancient India embraced it. Hindu cosmology operates on timescales that dwarf human comprehension. One day for the creator god Brahma equals 4.32 billion years. One night, another 4.32 billion. The universe is created at dawn, destroyed at dusk, then reborn again. This cycle, called a kalpa, repeats endlessly. The god Shiva dances the cosmic dance. Nataraja, the dance of creation and destruction. In his hands, a drum that beats the rhythm of time. In his palm, fire that consumes all things. And the dance goes on forever, in an endless circle. No beginning, no end, just infinite cycles. This wasn't philosophy. This was mathematics waiting to be written down. While medieval Europe struggled with the very concept of nothing, Indian mathematicians were doing calculus with it. The 7th century, mathematician Brahmagupta writes the first formal rules for zero. 0 plus a number equals that number. 0 times a number equals 0. Subtract a number from itself, you get 0. Simple now, revolutionary then. But Brahmagupta went further. What happens when you divide by 0? In most mathematical traditions, this question was forbidden. Dangerous, undefined. But India said 1 divided by 0 equals infinity. The 12th century, Bhaskara II takes it further. He describes infinity not as an error, but as a number. A quantity, something real. A quantity divided by 0 becomes infinite. In this quantity consisting of infinity, there is no alteration, though many may be inserted or extracted. Infinity plus 1 equals infinity. Infinity minus infinity equals, well, that's complicated. But the point is they were comfortable with infinity. Where Greek mathematics saw a wall, Indian mathematics saw a doorway. December 22, 1887. Erode, Tamil Nadu, India. Srinivasa Ramanujan is born into a poor Brahmin family. He shows mathematical talent early, but he's obsessed. He ignores every other subject. He fails his university exams. Not because he's not brilliant, because he only wants to do mathematics and nothing else. Without a degree, his options are limited. He becomes a clerk, a shipping clerk in the Madras Port Trust. Salary 25 rupees per month. By day, he records cargo shipments. By night, he does mathematics. No textbooks, no teachers, no libraries, just notebooks, hundreds of pages filled with formulas. He claims the goddess Namagiri Thayar, the family deity, appears in his dreams and writes equations on his tongue. When he wakes, he writes them down. No proofs, no derivations, just truths revealed from somewhere beyond logic. Ramanujan knows he's discovered something, but he's isolated. No one in India can understand his work. So he writes letters to British mathematicians, hoping someone will recognize what he's found. Most ignore him. One letter is polite but dismissive. Another never replies. Then, in 1913, he writes to G. H. Hardy at Cambridge. Hardy later recalled, "I had never seen anything in the least like them before. A single look at them is enough to show they could only be written down by a mathematician of the highest class. But also, they must be true because, if they were not true, no one would have the imagination to invent them." Some formulas Hardy recognized as known results. Others were wrong. But many, perhaps most, were completely new and profound. Hardy arranges for Ramanujan to come to Cambridge. 1914. The journey takes weeks by ship. Ramanujan, a devout Hindu, vegetarian, arrives in cold, grey England. Cambridge, Gothic buildings, ancient traditions, and Hardy, brilliant but cold, deeply rational, trying to understand this clerk from India who speaks to goddesses. What did Ramanujan discover? Imagine trying to calculate pi. 3.14159. Ramanujan found infinite series that converged to pi with stunning efficiency, each term adding 8 more correct digits. Normal methods might need thousands of terms. Ramanujan's? A dozen. He discovered formulas for partition numbers. If you have n objects, how many ways can you divide them into groups? For small numbers, you can count. For large numbers, it becomes impossibly complex. Ramanujan found an exact formula. He worked with modular forms, Mach theta functions, concepts so advanced they wouldn't be fully understood until decades after his death. And always, the hallmark: no proofs, just assertions. This is true. Hardy would spend months proving what Ramanujan wrote down in minutes. Where did they come from? Ramanujan insisted the goddess. In his dreams, mathematical truths given as divine revelation. Hardy, the atheist rationalist, didn't believe in gods, but he couldn't deny the mathematics. England was killing him. The food, he couldn't eat most of it. Vegetarian options were scarce in 1910's Cambridge. He lost weight. The weather, India is warm, England is cold and damp. He got sick repeatedly. The war, World War I was raging. Resources were scarce, life was hard, and perhaps isolation. Far from home, far from his culture, far from the goddess who whispered to him. 1917, he becomes seriously ill, probably tuberculosis, possibly something else. He spends months in hospitals and sanatoriums. There's a famous story. Hardy visits him in the hospital, making small talk. Hardy mentions he took taxi number 1729 to get there. Rather a dull number, Hardy says. Ramanujan immediately responds, "No, Hardy. It is a very interesting number. It is the smallest number, expressible as the sum of two cubes in two different ways. 1729, 112, 910. Even dying, his mind saw patterns invisible to others." 1919. The war ends. Ramanujan returns to India, weaker, sick. 1920. April 26, age 32. Srinivasa Ramanujan dies. He left behind notebooks, thousands of formulas, many still not fully understood. Ramanujan's lost notebook, discovered in 1976, contained formulas that anticipated mathematical discoveries made decades later. His work on partition functions led to breakthroughs in number theory. His infinite series are used in modern physics, string theory, quantum mechanics, black hole thermodynamics. The number 1729, now called the Hardy-Ramanujan number, appears in computer science, algebra, even music theory. But beyond specific formulas, Ramanujan represents something profound. India's mathematical tradition, where infinity wasn't feared, but embraced. Where zero wasn't nothing, but everything. Where mathematics could be spiritual. While European mathematics built up from axioms, step by logical step. Ramanujan seemed to see the destination first, then work backward. Hardy described him as a mathematician who has never been equaled in intuitive insight. But also, every positive integer is one of Ramanujan's personal friends. He had a relationship with numbers, a dialogue, as if they spoke to him. Was it the goddess? Was it savant-level pattern recognition? Was it cultural, a mind trained by a tradition comfortable with infinity? We'll never know. Did a goddess really whisper mathematics to Ramanujan? Hardy didn't think so, but Hardy also couldn't explain where the formulas came from. Maybe the goddess is a metaphor for intuition so powerful it feels divine, for insights that bypass conscious reasoning and arrive fully formed. Or maybe, in a tradition where infinity is as natural as breathing, where the cosmos dances in endless cycles, where zero and infinity are two sides of the same coin. A mind like Ramanujan's could access mathematical truths directly, not through proof, but through vision. The West gave mathematics rigor. India gave it imagination. Ramanujan died at 32. Imagine what he could have done with 40 more years. But even in his short life, he showed us something crucial. Mathematics isn't just logic. It's creativity, intuition, beauty, and maybe, just maybe, if you listen carefully, the numbers do speak. 1729. The Hardy-Ramanujan number. Now you know it too. And somewhere, perhaps, Ramanujan smiles. Welcome to infinity. In India, they were never afraid of it.